Properties of metals. Most of the elements on the periodic table are metals, including gold, silver, platinum, mercury, uranium, aluminium, sodium, and calcium. Alloys such as brass and bronze also are metals. Metals are located on the left side and the middle of the periodic table. Group 1A and Group 2A. The alkali metals are the most active metals. The transition elements are also considered metals. The basic metals are the element to the right of the transition metals. The bottom two rows of elements beneath the body of the periodic table are the lanthanides and actinides, which are also metals. Metals are shiny solids at room temperature, except mercury, which is a shiny liquid element with characteristic high melting points and densities. Many of the properties of metals, including large atomic radius, low ionization energy, and low electronegativity, are due to the fact that the electrons in the valence shell of metal atoms can be removed easily. One characteristic of metals is their ability to be deformed without breaking. Because the valence electrons can move freely, metals are good heat conductors and electrical conductors. Properties of non-metals. The non-metals are located on the upper right side of the periodic table. Non-metals are separated from metals by a line that cuts diagonally through the region of the periodic table, contains elements with partially filled p orbitals. Technically, the halogens and noble gases are non-metals, but the non-metal element group usually is considered to consist of hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Non-metals have high ionization energies and electronegativities. They are generally poor conductors of heat and electricity. Solid non-metals are generally brittle with little or no metallic luster. Most non-metals have the ability to gain electrons easily. Non-metals display a wide range of chemical properties and reactivities.
Physical properties of metal and non-metal. Dear student, you might have noticed some of the daily used objects are hard or brittle. Some are shiny, while some are lustrous. Have you ever thought why there is so much change of properties among different objects? We mainly classify these objects as metals and non-metals Let's understand the physical properties of both of them. A metal is a solid material that is typically hard, shiny, and features good electrical and thermal conductivity. Metals are generally malleable, that is, they can be hammered or pressed permanently out of shape without breaking or cracking, as well as fusible, that is, it is able to be fused or melted, and ductile, which means they are able to be drawn out into a thin wire. Currently, 91 out of the total 118 total elements on the periodic table are classified as metals. It is because of their malleability and ductility that metals can be given different shapes according to our needs. Non-metals are the elements that do not conduct heat and electricity and are neither malleable nor ductile. They are brittle. Non-metals are not lustrous. These are generally soft and not strong. Example: carbon, oxygen, hydrogen, nitrogen, chlorine, bromine, etc. Non-metals are bad conductor of heat and electricity. Plastics and wood protects us while handling hot objects. Chemical properties of metals. Metals are electropositive elements and are very reactive. Metals tend to lose electrons easily and form positively charged ions. Therefore, metals are called electropositive elements. Sodium metal forms sodium ions, Na positive. Mg forms positively charged magnesium ions, Mg2 positive. And aluminium forms aluminium ions, Al3 positive. Let's study the chemical properties in detail. Metals usually have 1 to 3 electrons in the outermost shell of their atom. For example, sodium, magnesium, and aluminium have 1, 2, and 3 electrons respectively in the outermost shell of their atom. Metal atoms have tendency to lose electrons and form cations. This tendency is called the electropositive nature. While Zn, Cd, Sn and Pb have moderate electropositive nature. Metals generally have low electronegativity, that is, tendency to attract electrons in the state of molecule. For example, metals like Ca, Mg, Al, Zn have low electronegativity. All metals act as reducing agents. Strongly electropositive metals like Mg, Al and Cr act as strong reducing agents, while moderately electropositive elements like Zn, Cd, and Sn act as moderate reducing agents. Strongly electropositive metals like Na and K react even with cold water to produce their hydroxides, and they evolve hydrogen gas. Highly reactive metals like Na, Mg, and K react with dilute mineral acids like HCl or H2SO4 to form salt and hydrogen gas. These reactions are displacement reactions. Almost all metals combine with oxygen to form metal oxides. Metal plus oxygen gives metal oxide. For example, when copper is heated in air, it combines with oxygen to form copper 2 oxide, a black oxide. 2Cu plus O2 gives 2CuO. Similarly, aluminium forms aluminium oxide. 4Al plus 3O2 gives 2Al2O3. How do metals and non-metals react? We very well know that elements on reacting have a tendency to attain a completely filled valence shell. Let's understand the reaction between metal and non-metals by doing experiment. We very well know that a sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell becomes the outermost shell, and that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So, there is a net positive charge, giving us a sodium action, Na positive. On the other hand, chlorine has 7 electrons in its outermost shell, and it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L, and M shells. This gives us a chloride anion, Cl1 negative. Sodium chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride. Occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the Earth's crust are known as minerals. At some places, minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Several steps are involved in the extraction of pure metals from ores. Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the ore. Metals low in the activity series is very unreactive. The oxides of these metals can be reduced to metals by heating alone. 2HgS S plus 3O2G heat 2HgO S plus 2SO2G. 2HgO S heat 2HgL plus O2G. The metals in the middle of the activity series such as iron, zinc, lead, copper, etc. are moderately reactive. These are usually present as sulfides or carbonates in nature. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. Properties of ionic compound. The properties of ionic compounds relate to how strongly the positive and negative ions attract each other in an ionic bond. Ionic compounds form crystal lattices rather than amorphous solids. Although molecular compounds form crystals, they frequently take other forms, and molecular crystals formed are softer than ionic crystals. High temperatures are required to overcome the attraction between the positive and negative ions in ionic compounds. Therefore, a lot of energy is required to melt ionic compounds or cause them to boil. Ionic crystals are hard because the positive and negative ions are strongly attracted to each other and difficult to separate. However, when pressure is applied to ionic crystal, then ions of like charge may be forced closer to each other. The electrostatic repulsion can be enough to split the crystal. That is why ionic solids are also brittle. Although they conduct in molten form or in aqueous solution, ionic solids do not conduct electricity very well because the ions are bound so tightly. Electrolytic refining and corrosion. The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically. In this process, the impure metal is made the anode, and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Corrosion is the gradual destruction of materials, usually metals, by chemical reaction with its environment. Iron, when exposed to moist air for a long time, acquires a coating of a brown substance called rust. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. For example, iron is the most widely used metal, but it is never used in its pure state. This is because pure iron is very soft and stretches easily when hot. But if it is mixed with a small amount of carbon, about 0.05%, it becomes hard and strong.